We're going to continue talking about statistics and diving into some more vocab and different types of statistical research. So let's start with some vocab. A hypothesis is a claim about a characteristic of a population. For example, we might say that our hypothesis is that Italians, the average Italian is 6 feet tall or greater. Obviously, that is baloney. I have never done any research about the height of Italians, but let's say that that is our example. A parameter is a numerical description about a population characteristic. A statistic is a numerical description of a sample characteristic. So parameter and statistic are going to be very, very similar. The only difference, and it's a big difference, is that the parameter represents the population and the statistic represents the sample. So remember, the population is the entire group of interest. If our hypothesis is about the height of Italians, then our parameter is going to be describing probably the average height of all Italian people. Our population will be Italian people. Obviously, that's an enormous population. There are a lot of Italian people. A statistic is a numerical description of that sample. So we would choose, a handful, obviously a relatively large handful, 1,000 Italian folks, and we're going to measure their heights. The statistic would be the average height of the people we measured. The parameter is the average height of all Italians. So the parameter is often going to be impossible to find. You're never going to be able to actually measure all Italians or even ask all Italians how tall they are. The statistic is the value you're actually going to find. Either you ask 1,000 Italians how tall they are, or maybe you actually go out and measure 1,000 Italian people. It doesn't matter. The statistic is going to be the average height of the Italians that were in your sample. The parameter would be the average height of all Italians. We use statistics to represent parameters when oftentimes those parameters are impossible to find. Okay, so for example, a researcher thinks that females in the US are taller than females in Europe. That's our hypothesis. This one actually involves two populations, right? Obviously, we have European females in Europe and females in the US. There must also be two samples then, right? Because we're going to have to take a sample of women in Europe and a sample of women in the US. A census is basically impossible in this example. How are you ever going to survey or measure the heights of every female in the US and every female in Europe? That's an incredible number of people, and it would be prohibitively expensive. So we're never going to find the actual heights of females in Europe or in the US. So the parameters are going to be basically impossible to find, but those would be the actual heights. The statistics are going to be the heights of the people that we sample. So we're going to find a way to study a group of European women and a group of United States women to find their heights, and we will use those statistics to represent the unknown parameters. Once we've chosen a method to select our sample and have done so, it's time to gather our data. There are basically 4 methods that can be used to collect this information. They are a little bit different in how they're done and what they're used for. We've talked about 3 of them, so we're only going to really focus on the last one, which is simulation. So let's just very briefly review. A survey is when you ask people something, right? So you just ask them how they feel, or you ask them how tall they are. An observational study is when you just measure or observe people or subjects doing something to see what happens. So that's where the gaming company watches a group of teens playing a selection of video games and writes down which ones they play the most, right? You're not doing anything to the test subjects, you're just, or the study subjects, you're just watching what they choose to do. And then an experiment is where you separate the subjects into 2 groups, an experimental group where you do something and a control group where you don't. So like you're timing rats as they go through a maze, and you divide them into groups and you give one group some extra sugar and you don't give the other group any sugar. You've got a control group that didn't get sugar and then an experimental group that did get sugar, and your hypothesis would be whether or not, the hypothesis might be that sugar increases their time or that it decreases their time, whatever. So those are those 3. The new one is a simulation. A simulation uses a model to reproduce the conditions of a situation or process so that the simulated outcomes can closely match real-world outcomes. Simulations allow you to study situations that are impractical or dangerous to create in real life. So I took a class in college called optimization, and it's all about using mathematical systems and mathematical processes to simulate and to optimize real-world situations. So one project was to figure out where in Montana, in rural Montana, we should have rural ambulance centers. And so we were trying to figure out where should we place these ambulances so that we can best serve all the people of rural Montana, because some of these towns with 40 people in them can't afford to have an ambulance there all the time. Now, you can't just like put them out there in rural Montana and say, okay, let's see what happens. Let's see how many people die because they don't get an ambulance. So we used a simulation, a computer simulation, to estimate the number of emergencies and the level of life threateningness that each emergency had, and how long it took the ambulance to get there. So we could say, well, let's say we had these here for a year. Here's the average number of emergencies per capita. Here's how many people die normally from those emergencies. Here's how many people die if they get served by an ambulance versus if they don't get served by an ambulance. And we were able to run thousands and thousands of these in just a few minutes. Nobody died. Nobody got hurt. It was all in a computer, but we were able to kind of see, okay, if we put the ambulances in Stevensville and in Two Dot, this many people will die because we can't get the ambulances there in time. But if we put the ambulances in Noxon and in Webo, fewer people died because the ambulances were better positioned to serve more folks. Those kinds of things are simulations. We also did one in a hospital. How many emergency room beds do we need versus how many ambulance bays versus how many operating rooms? How do you best serve the needs of a population by how you set up the hospital? How many nurses? How many doctors? How many medical techs? How many CNAs? All those things. And you can change all of that and see what happens. Then change it again and see if the results change, and you never actually have to mess with real world stuff, and allows you to figure out what the best option is before you start impacting real world situations. So that's a simulation. So I'm going to give you, I guess, 3 different scenarios here, and I want you to determine if it's a survey, an observational study, a simulation, or an experiment. So number 1, a company shows 5 different commercials to a group of students and records their reaction. Is that a survey, study, simulation, or experiment? That would be a study, right? We're showing just commercials and then we're just recording their reactions. We're observing what they do. Number 2, scientists study the behavior of 2 groups of rats, sugar and no sugar, to determine sugar's effect on their ability to complete a maze. I kind of already hinted at this one, but it's an experiment, right? We're actually influencing the people or things that we are studying. And then finally, the school board is interested in parents' thoughts on building new schools in the district, so a questionnaire is sent home in the monthly newsletter. That would be a survey. Okay, last, just like we've talked about in the past, we have to avoid bias when we are conducting surveys or experiments. So bias in surveying occurs when one of the 4 conditions are met. If questions are confusing or they don't provide enough information, if questions encourage a particular response, if questions cause a strong reaction or are too sensitive to answer truthfully, or if questions address more than one issue at a time, they are biased questions. Just like when you're finding samples, you have to avoid bias by not just asking your 5 best friends what their favorite restaurant is, right? You probably have things in common. That's not fair. You also have to be careful how you word questions to avoid bias. Or when you're looking at results of studies, it's important just as a person that you understand, hey, this question is biased. This isn't going to be a fair study. It's good to be on the lookout for these things because sometimes people will use biased questions on purpose to get the results that they want. Bias in experiments can occur when members of the control and experimental groups are not chosen randomly. So let's go back to our rats example. I've got a bunch of rats and I've ran them through a maze. If I take the 5 fastest rats and I give them sugar before they do the maze, and I take everybody else and I don't give them sugar, and then I compare their times, that's not fair. The rats that got the sugar were already the fastest. It needs to be completely random for it to be fair. So we're going to look at a few questions and determine whether or not they are biased, and then maybe state why they're biased if they are. Number one, do you like animals, and would you ever consider having a dog or cat as a pet? Is this a biased question? Let's go back to the reasons that, or the things that can make questions biased. So is this question confusing or not provide enough information? No, I'm pretty aware of what it's asking. Does it encourage a particular response? Do you like animals, and would you consider having a dog or cat as a pet? No, I'm not encouraged to answer one way or the other. Does it cause a strong reaction, or is it sensitive? Not really. I guess unless you have a strong opinion about animals, but then that's going to happen anyway. Or does it address more than one issue at a time? Now that one I think is a problem. Do you like animals, and would you consider having a dog or cat as a pet? Maybe you love animals, but you're just not much of a dog or cat person, or you're allergic to dogs and cats, but you love goats and fish. I mean, it's hard to say. There's a lot of animals you could like without necessarily being a huge fan of dogs or cats. So this one's biased because it addresses more than one issue at a time. I'm just going to say number 4, and you can go back to look if you're confused. Number 2, what type of music do you listen to? Is it confusing or not provide enough information? No, it's pretty clear. Does it encourage a particular response? No. Does it cause strong reaction, or is it too sensitive to answer truthfully? No, not really. And does it address more than one issue at a time? I don't know that it does. So I think you could say this is unbiased, but it also makes a certain assumption that should be at least considered. It's assuming you listen to music. Right, so some people might argue that this is in fact biased because it assumes you listen to music before asking you what kind of music you listen to. That's fairly nitpicky, so it depends, I guess, on what the purpose of the survey would be. Finally, number 3. To study the effects of a new training method, a dog trainer tries the old training method on a group of terriers, and it tries the new method on an experimental group of retrievers. Is that a biased experiment or not? If we go back, bias in experiments occurs when members of the control and experimental group are not chosen randomly. Does it sound like these dogs were split into groups randomly? I don't think so. He put all the terriers in one group and all the retrievers in the other group. So maybe either a specific training method is better for one breed of dog over another, or maybe one breed of dog is just smarter than the other. I mean, that happens. So this is definitely a biased experiment. He would have had to mix the groups at random and then try the new methods to have any hope of getting valid results. Homework for this video is to write one biased and one unbiased survey question that could be asked to gauge interest in a new menu item at a restaurant. So you've got a restaurant that's added a menu item, and they want to ask customers what their interest in that menu item might be. So on Teams, there's going to be a document you can edit that will have space for a biased question and an unbiased question. You can have some creativity with this, but I'd like you to write one of each and then turn it in on Teams. Have a great day, and I'll talk to you guys later.